This ship was built to do something that looks wrong at ocean scale. It can lift pieces of the offshore world that are heavier than entire buildings. Not containers, not small machinery, not cargo that can be rolled across a normal deck. It lifts steel structures so large that they look like parts of a city. Its name is Sleipnir, and it is one of the most powerful crane vessels ever put to sea. The first thing you notice is not the hull. It is the two giant cranes rising from the deck like industrial towers. Each crane can lift about 10,000 metric tons. Together, they can work in tandem for a combined lifting capacity of 20,000 metric tons. That number only starts to make sense when you see what the vessel is built to move. Offshore platform topsides. Steel jackets standing like underwater towers. Giant modules packed with pipes, machinery, decks, and living spaces. Foundations and structures for the offshore energy world. Sleipnir is not trying to carry cargo like a normal ship. It is trying to turn the sea into a construction site. Most offshore structures used to be assembled in smaller pieces. That meant more work offshore, more lifts, more weather delays, and more risk. Sleipnir changes the question. Instead of asking how to assemble a giant structure piece by piece at sea, it asks something more brutal. Can we lift the whole thing at once? The answer depends on more than crane size. It depends on the ship underneath the cranes. Sleipnir is a semi-submersible crane vessel. That means it can sit low and wide in the water, using submerged hulls for stability. Its deck is about 220 meters long and 102 meters wide. That is not a normal ship deck. It is closer to a floating industrial platform. The vessel can change its draft from about 12 meters to about 32 meters. By ballasting down, it lowers its center of motion and becomes steadier for heavy lifts. When a lift begins, nothing happens quickly. The cranes do not simply snatch a structure out of the sea. The load has to be connected. The rigging has to be balanced. The ballast system has to prepare for the changing weight. The vessel, cranes, waves, wind, and cargo all become one connected system. Then the lift starts. Thousands of tons of steel slowly leave their supports. For a moment, the entire weight is hanging from the cranes. The ship has to resist that force without twisting, rolling, or drifting out of position. This is why Sleipnir looks so wide. This is why the cranes are not just tall, but massive at their bases. This is why the operation looks slow from far away. Slow is control. Slow is how you stop a giant load from becoming dangerous. One of Sleipnir's most impressive jobs was lifting the Leviathan topside, about 15,300 metric tons. It also removed the Jotunby jacket, an 8,100 metric ton structure. Then it removed the Brent Alpha jacket, around 10,100 metric tons. It has also installed huge new structures, including the Johan Sverdrup P2 jacket. These are not decorative records. They change what can be built on land and moved offshore later. If a structure can be lifted as one piece, more work can happen in a controlled yard. Less work has to happen in open water. That can save time, reduce offshore risk, and make larger designs possible. But every advantage comes with pressure. When a 10,000-ton load is in the air, there is no casual movement. Wind matters. Wave motion matters. The exact angle of every sling matters. The ballast team has to think ahead of the load. The crane operators have to move with millimeter-level discipline at a scale that feels impossible. Sleipnir also has another unusual detail. It is a giant crane vessel that can run on LNG as well as marine gas oil. That does not make the work small, but it shows how new offshore machines are being built for a different era. They are larger, more specialized, and expected to work across oil, gas, decommissioning, and offshore wind. In one job, Sleipnir may install a new structure. In another, it may remove an old one from the sea. The same pair of cranes can build the future and dismantle the past. That is what makes the vessel feel different from a normal ship. It does not just travel across the ocean. It arrives, holds position, lifts a piece of industry into the sky, and changes the shape of the offshore field. Most ships move things from one place to another. Sleipnir moves the limits of what can be lifted at sea. It is part vessel, part crane, part floating foundation. And when both cranes begin to lift, the ocean stops looking like water. It starts looking like a worksite for giants. The most important part is that the vessel is not only strong. It is organized around the lift from the beginning. The deck, cranes, ballast tanks, thrusters, power systems, and crew all exist around the same problem. How do you hold a giant object steady when the sea refuses to stand still? That is why the vessel's size matters, even when the cranes get most of the attention. A narrow ship with huge cranes would not be enough. The platform below the cranes has to be wide, heavy, and predictable. It has to remain calm while the load changes the balance of the entire vessel. During tandem lifting, both cranes must share the work. If one side takes too much load, the structure can twist or the rigging can become dangerous. So the lift is choreographed before it happens. Engineers calculate the load path. Crews prepare connection points. Operators watch the sea state, the crane angles, and the vessel motion. Even the weather window becomes part of the machine. The operation may look like a slow vertical movement, but underneath that movement is a full engineering campaign. That is why vessels like Sleipnir are valuable for decommissioning old offshore fields. They can remove huge pieces without cutting everything into smaller parts at sea. They can also install new structures that arrive more complete than older offshore designs. In both cases, fewer separate lifts can mean fewer chances for the ocean to interrupt the job. Sleipnir is not just bigger for the sake of being bigger. It is bigger because offshore structures have become bigger too. And when the work gets too heavy for ordinary ships, the answer is not a faster vessel. The answer is a ship that can become the crane, the work platform, and the stable foundation at the same time.